Welcome to Amateur Redneck Workshop. I'm Harold, and we're going to finish up on the torch today, the plasma torch. And I don't know anything about the right speeds and air pressures and stuff, so there's going to be a lot of playing around, and I'm going to have to scrounge around here and get up a lot of scrap metal to waste so that I can figure out how to do it. But I already know how this video comes out, so I'm not going to tell you though. You know, as the demographics change, the language changes. And if you're from East Texas or somewhere, or you're older, you know what light bread is. Now my boss lady, she's from East Texas, and so we go to Target the other day, and there's a couple of young folks working there, a male and a female people, and she asked them, where's your light bread? And they looked at each other kind of confused like, and the guy says, is that some kind of bread, some brand of bread or something? And then he said, well, bread's down on aisle such and such, you know. And they'd never heard the term. So here you are, your language gets worn out and used up. And I've been watching all this Second Amendment stuff, and I'd say if you got guns and you got some ammo, go to the range and shoot it up, because you may not have a chance much longer. It's not looking too good. And so enough of that. Anyway, I do a lot of testing on a solid state relay here to make sure that it's going to handle the job, and then Bozo comes along to give me a hand. Might as well have been Bubba doing the testing, I guess. But anyway, Bozo comes along and gives me a hand with it all. But, well, just watch the video and see how things come out. Well, I was watching a video where Everett used one of these little solid state relays, and he mounted a heat sink on it because he's going to have a heavy load running on it. And I'm not anticipating a heavy load. So the load that I've put on here for testing is a spotlight, and I'm pretty sure that it's a great deal more of a load than that torch. The switch down there is not, you know, it doesn't look to me like it's built to handle a bunch of amperage, you know. So I'd like to give you the warning here. Don't do this at home. This is totally, completely unsafe, maybe illegal in some countries, and it could lead to death or serious injury. Don't do this, what you see me doing. I'm a professional redneck and prepared to accept the consequences of my actions. So I turned the little relay over on its side so that the back of it would not be soaking its heat off into the concrete. And I can use a little Harbor Freight ultraviolet or infrared temperature sensor to see how hot the thing's getting. So hang loose and I'll go get it. Alright, I got the detector, sensor, whatever. Current temperature is room temperature, 82 degrees Fahrenheit. Get it down there far enough you can see it. I don't know how much that is in Celsius. You can calculate it if you really care. Alright, so we're going to let it sit there and run like that with the spotlight pulling that load. We'll let it run for, well, I imagine it's going to heat up. It's going to heat up in 15 or 20 minutes. So we'll give it at least that long. Well, I've been at this for several minutes, and the darn thing's still at room temperature, which is 82.5 degrees Fahrenheit. And it's been about that 10 minutes. I don't think this thing's going to warm up under the small load that I've got, so I'm just going to put some double-sided tape on the back and stick it to the wall of my enclosure. I've got, as you can see there, I've got little power supply with a voltage regulator, and that voltage regulator is putting out 5 volt DC to trigger the thing, and the smart valve will either give it 5 volts DC or 10 volts, one or the other, Very low amperage, of course, but enough to trigger the thing. And so even though this has a spot on the back for a heat sink, I think that in my application it's not going to be required. I've tested it here and the temperature hasn't changed. It's staying room temperature, so I'm going to assume that I don't need a heat sink on this one. Sometimes if you've got an application where you're running 110, 120 volts, 200 volts or something, you may well need a heat sink, because that'll put up a lot of heat. I think what's going through the little switch on this torch is not going to put up any heat at all. So there you go. Case settled. Well, we're going to move the limit switches from the e-stop connection to just a different input. So here's the e-stop down here, right here on this connector. I'm going to move up to this connector and use one of the spots on there. I got a light so that I can tell for sure which one's the ground and all that sort of thing. It's just, old eyes have a hard time seeing what's lined up with what else. But anyway, you see what I'm doing. These connections go to the stepper motors, or at least to the stepper motor controllers. So they're not going to have to move. And then I'll have to hook in an output, and I think that's this connector up here. I'll have to double check everything, of course, to be absolutely certain. There is a relay on there that handles things too. So I don't know. I've got to double check which one of these should be the outputs, because I've got to have an output to the torch to turn it on. I have to have a way to activate the switch in the torch, so I'm going to open it up and solder a couple of wires to the switch so that I can activate them externally. Excuse me, my voice is not doing too good. I've still got a cold. I don't want to turn things sideways. Alright, anyway, here's the switch. And what I plan to do is solder a wire onto each side here. I think you can see it. And run them out of here, and then I can plug them into the controller there and run it. While you guys take a nap, I'll try to find some wire and other things like that. Okay, I've got the wires pulled off this little switch, which doesn't amount to much of anything. It's just two pieces of metal that get contact to a washer. It's got a spring behind it, as you can see right there. And I don't want to melt any of that. So I took the wires off, and I'm going to take this guy and solder him onto one of them and another one just like him and solder on the other one. And they will run back out of the handle of the torch, and then I can hook on two of them with wires that come from the relay on the smart bob there. So I'm not going to video while I solder this, because it's, number one, distracting to me, and number two, boring as everything to watch you guys solder a couple of wires together. Whenever I'm going to solder wires to something, I always tin the end of it there in advance. If it's two wires, I tin both wires, and then I melt them together. This way you got a good contact with the wire, and when you make the joint, you'll have a good contact in the joint and good contact with the wire. It's just the way I do it. We're going to be coming back out of the handle. And now all I've got to do is maneuver that switch around to put it all back together. That wasn't easy the last time I looked in to see what was in there, and it won't be any easier this time. I like this kind of crimper. They're normally pretty expensive, you know, but sometimes you feel like spoiling yourself. I got this one for $15 off of Amazon. Only comes just with the one set of jaws. But you can kind of start the ratchet one latch and then position this thing with it holding onto the clamp for you. And then you can make a nice tight connection, I thought. Not very good. Alright, back to the drawing board, get some more female connectors and try again. Alright, I stripped the wire back further, make sure that they went all the way up in there where I could see them really good coming through. And then I fixed them in there. They're in there tight now. Okay. It's a shame I went through 6 connectors before I stripped it back and got it right. But there you are. We got that. Now then, go put this guy back where it came from and string some wire from the wire that comes from the computer. All right. I'm coming from here. I'm going over to here. I'm pretty sure you can see that. I can see that. So I'm going to run the wire up over this guy and just out there to it. It won't take much, a couple feet of wire. That includes both pieces, you know. And it will be ready to roll. So I'm going to go ahead and make up the wire, and then we'll come back and see what it looks like when I'm through. Well, this is just to see if the torch will come on. If it does, we'll reset everything and start out, maybe try to make a cut. I don't know. Well, it didn't start the torch by itself, so I don't know why. I'll have to check into this. First time around it cut a groove and didn't penetrate. I've got the amps turned up all the way, so let's see what we get here. Still didn't penetrate. I'm going to have to get the torch a little closer to the metal. I may try a thinner piece of metal until I get this worked out. that's what it did right there. It it cut a groove, but it didn't penetrate. So I have to slow it down. I'll have to go into the little code there and slow down the travel. And also, I guess I need to get a thinner piece of metal to put on there. So you guys take a little nap. Thinner metal, another try. I forgot to slow it down. It did penetrate in a few places, and but it welded itself back together. So this time I'll go into the test code, and I'll actually slow the little sucker down. I don't know how come I forgot, but I guess all the excitement, huh? I guess we should try again. It might be the right speed now, but I had the torch too low and it caught the metal and dragged it along with it. But it did get pretty good penetration, so I'll fool with it a little bit more. This piece of metal is getting hot and nasty, so let me cool it off a little bit and I'll set it up and we'll try again. Now another try. I'm letting it wait too long before I start moving. I'll cut the time back and then we'll start over. Alright, we'll go get it. Well, it penetrated and it dragged the metal with it a little bit because I went across these spots where I'd already cut. And tons of slag on the back of it, as you can see. It's pretty nasty. But I'm on the right track. I need to speed up a little bit now. But I don't have another piece of metal handy. And see, it wasn't too bad when I was going a little bit faster. And then when I slowed down, well, penetrated good, but got a lot of slag. So at this point, we'll check on Bubba and Cooter. And after all that testing I did with that solid state relay, I let the magic smoke out of it. And so I read more on this smart bob, and I just put the torch switch right onto the smart bob relay itself. And I don't need an external relay. It's doing a good job just like it is. From here, it's just testing to get the speed right. And I don't have a good idea of what's the right speed because I'm not a a welder or a plasma torch user. In fact, if you'll look back at my previous videos, I haven't cut a piece of metal with any kind of torch in any of them, except the one where I bought the plasma cutter and mangled a few pieces. So, definite lack of experience. Anyway, thanks for watching. Let's go see what Bubba's doing. It was a dark and stormy day, and an old redneck was going to tell a story. Now, I'm going to use a word here that might sound a little funny, but you can add or subtract, probably subtract letters from it till it makes sense to you. Anyway, it seems that Bubba and Cooter had joined the service, but Cooter had gone in the Navy and Bubba had gone in the Marine Corps. And they'd got out of boot camp, and they was back home on leave. They were going over this big apartment building to pick up Cooter's girlfriend, Mary Lou. And so Cooter told Bubba, wait down here on the corner while I go up there and get her, and we'll be back in a minute. So Bubba's standing around there, and he looks around, there's a kid with a 5-gallon bucket and a stick, and he's stirring away. Bubba walks over there and looks at the kid and says, hey kid, what do you got in the bucket? Kid says, bull shirt. Bubba kind of drawing back. What? Bull shirt? What are you making? Kid says, I'm making a sailor. Oh, Bubba just kind of danced a little jig. That just tickled him something awful. He was ready to wait for Cooter to get back down with, Mary Lou. And so sure enough, here comes Cooter with Mary Lou. And Bubba says to Cooter, he says, look here, Cooter. He says, go over. You said kid over there? He says, yeah. I said, go over and ask him what he's got in that bucket, then ask him what he's making. Cooter says, all right. So he goes over there and says, hey, kid, says, what you got in the bucket? Kid says, bull shirt. He's still stirring away, Cooter kind of took aback. So, well, just what are you making anyway, kid? Kid says, I'm making a sailor. Whoo, boy, that just set, Cooter on fire. He turned all red, and his hair's kind of short, mind you, on account of him, being in the military. What there was of it stood on the end. He stood there and thought as hard as a redneck could, for a few seconds, and looked at that kid, and he said, why don't you make a Marine? Kid says, oh, don't have enough bull shirt. Well, that's all, folks. Y'all try to subscribe if you're not already a subscriber. Leave a comment if you got something to say. And above all, remember, keep on keeping on. Bye now.